So using our triangles, I'll be able to solve the next example here. A triangle that involves a 60 degree. Looking at the triangle, I can right away come up with the ratio between these three lines. I would expect my hypotenuse to be twice as long as its shortest side. So what do you know right away? The y will now be 6, half as long as its hypotenuse. Y equals 6 right away. Now, of course, you don't have to solve it this way. You will still be able to set up your triangles using SOHCAHTOA. You can go with cosine 60 degree equals adjacent over hypotenuse. And knowing how cosine 60 degree equals 1/2, this is the value that we came up with on the previous example. You will now be able to solve for y, giving us y equals 6. But as you can see, it takes a lot more steps to get to your answer if you set up an equation for this. You can speed up the process by using the ratio that you know for this triangle. I can also use the same concept to find x. So let's say I'll keep this one for now. I want to calculate x. And for now, I only know 60 degree and the 12. Here is the line opposite to this angle, and here we have the hypotenuse. If you are dealing with the opposite and the hypotenuse, using SOHCAHTOA, this will be the formula that I want to start with. So I'll be using the sine ratio to solve for x. We have the angle 60 degree. For now, we don't know the opposite side, but I have 12 for the hypotenuse. Using exact values, sine 60 degree will now give us root 3 over 2. Root 3 over 2, that's the ratio for sine 60. And here we have x divided by 12. Solving for x, as I multiply both sides by 12, the 12 will now be gone, and those two can be simplified to 6 and 1. Well, technically, 6 times root 3 would now be the length for this opposite side.